Okay, so this presentation will be on FireProtASR, web server for fully automated ancestral sequence reconstruction. That sounds familiar. So ASR is a very useful process in protein engineering that generates ancestral sequences to a given wild type. And it does this using evolutionary relationships and statistics. The ancestors of a given protein can be more stable, soluble, have better activity, etc., so they can be desirable in industry. However, the ASR workflow by itself is not very user-friendly, as James from our lab knows all too well. There's several steps you must perform for thousands of sequences, including multiple sequence alignment, clustering, filtering, establishing thresholds, generating the tree, etc. And there's software that do all these, but it's far more convenient to just have them in one place so users can submit a sequence and then obtain the ancestral predictions. So that's what this web server aims to accomplish, like AutoASR. The only necessary input is the FASTA file the user wants to generate ancestors from. The web server will use this sequence to check for any catalytic residues using SwissProt, and it will then conduct a blast search for homologous structures, but it will filter out any structure from the blast search that lacks the catalytic residues, in the case that the protein is an enzyme. So better quality homologs are obtained in this way. The web server will then process the sequences, removing those 20% longer or shorter than the query, and then also using a similarity threshold. It ultimately will leave only 150 sequences after this stage. There's then a sequence alignment with MAFT. They'll make an initial tree, phylogenetic tree with the pasta suite, and then they'll prune the tree to simplify it somewhat, and the user can choose specific branches of the tree to focus on for further calculations. Then the ancestral sequences are inferred from the initial 150 with IQ tree, and the user can specify the evolutionary matrix used in IQ tree. The sequences, once IQ tree finishes running, are then provided to the user in FASTA format, and the web server also generates homology models using ProMod3 of all of the desired ancestors, and the user can compare an ancestor to the initial structure and see the difference. And the authors validated this on haloalkane dehalogenase DHA. They analyzed 6 ancestors for this protein and determined their TM, midpoint of thermal denaturation, and solubility expression, and other parameters listed in Table 1. They found pretty promising data, namely that only one of these ancestors was insoluble and all the others were decently soluble, had decent yields, and all but one had significantly higher TM values than the wild type, and 2 had significantly higher activities than the wild type on haloalkanes. So overall, this demonstrated that the workflow could successfully conduct ASR and yield viable sequences very conveniently.